Dear students, in the last module, we have learned about operating system and its history. And today, we will let you know for different important concepts and terms being used in operating system paradigm. So we have discussed that interactive processing was very successful when users were able to communicate with their jobs which were running on the main computer, and they were able to communicate with the main computer using terminals which were associated outside that main computer room. However, here is one very important point is that there could be different kind of jobs that need to be run. Some jobs are time critical, so those need to be done within a particular time. However, some jobs are not to be done within a particular time. So system should respond within a particular time for certain jobs, and for other jobs it may not be very critical to respond in a very timely fashion. So for example, if we want to print the record of students of virtual university, so this job need to be done, but we are not saying that all of the record of all virtual university students should be printed within 24 hours. So this is a job that need to be done. And on the other hand, there could be one job like word processing, for example, typing the characters. So if user is typing the character very fastly and machine is not able to handle such typing accurately and perfectly and timely, so this means this job has a certain criteria, and the criteria is that this job need to be done within a particular time, at least within the constraints and the speed of the user on which he or she is entering the numbers or alphabets using a typing machine. So we are ending up to something that is known as execution of task under a deadline, and that deadline could be some few seconds, few minutes, or it may vary based on the activities. And such basically processing within the deadline is known as real-time processing, and we will discuss the real-time processing with an example. So computer performs the task in accordance with the deadlines in its external real-world environment. So I want to quote here the example of cruise missile and radar. So for example, if here is a cruise missile which has been launched from here and that need to be hit at this target. So you might be familiar with the cruise missile that it is operated very low near the earth so that it can not be caught with the radar, and it goes as very low, so it has many hurdles. So for example, if there is a tree which is coming, and then there is a huge building which is coming. So if cruise missile is going over here, and with the sensor it tries to understand that there is a tree in front of it, and if it process that if there is a time that, for example, it will take 2 milliseconds to reach this tree. So within these 2 milliseconds, this cruise missile need to make the decision that it should go somewhere like this and come back to its low profile nature task. So if this cruise missile is not doing this thing within 2 milliseconds, so this cruise missile will hit this tree and this will be destroyed. So it is not going to make the target. Similarly, then there is a huge building. So it will take only 1 millisecond to hit this building. So within this 1 millisecond, this cruise missile need to go upside and then come back to its low profile nature. And then it is going to the target and hit the target. So these times, 2 milliseconds and 1 milliseconds, are the deadlines which need to be met by the computer or by that job. So such a processing is known as real-time processing, where we have a certain deadline, and after that deadline there could be some problem. So here we have serious problem. And then if there is a radar, so if radar can identify some, for example, aeroplane or some fighter jet from enemy within a particular time, then it's fine. If radar can detect that enemy fighter jet after some time, when it has finished its target or it has achieved its goal, then there will be no need for the radar. So such basically systems are very time critical, and in the previous slide we have seen some low critical examples of real time as well, where user is entering some words using keyboard, and that should be processed via word processing application within some time, and that time is not very critical. So if the machine is missing some letters, it's not something that there is a danger for the life. But here in these applications, in cruise missile and radar system, there is a danger in the life. So such system need to be follow the real-time processing, and such a real-time processing can be achieved very easily when, for example, a system is servicing only one user. So there is a machine and that machine is servicing only one user. But however, we have learned in the previous slides and in the previous module that there is a huge computer and there are many users who are associated with that computer. So in such a system, real-time processing becomes a challenging task sometimes. So each machine had to be served more than one user at remote terminals. So how this is achieved? This is achieved by another concept in computer science known as time sharing. So the concept of time sharing is that there is a central CPU which is available here, and there are users, for example user 1, 2, 3, 4, 5, 6 users who are accessing the same computer or same CPU to perform their task. And this bold one or filled one user is being serviced at the moment. So this is what we call that it is being serviced, and or it is using the CPU. Then there is another which is called in the active line. So for example, when user 5 will be serviced, then user 6 will be serviced because it is in the active link. And when it will be serviced, then the active link will become over here. So it will be active link then. So this means in such an environment of time sharing, we have 3 states. So one user could be in active state, in ready state, or in waiting state. So all of these users would be either in the active state or in the ready state or in the waiting states to be serviced by the computer. And such time sharing can be implemented using multi-programming. And with multi-programming, you assign small slot to each of the job. So for example, there are 10 jobs which are being executed at one time by the CPU, by the main machine, and 10 users are watching their status via remote terminals, and your computer is implementing the multi-programming, which means each job will be given a small time interval. So this time interval could be very small. For example, 2 milliseconds, 3 milliseconds, 5 milliseconds, even in nanoseconds as well. So when such a small time slot will be given to each job, every user will be getting the response in a real time, and every user will be thinking that I am being serviced only by the computer. So at the moment there is no other job running on CPU. However, as we have mentioned that there would be 10 jobs. So what is the limit of that times computer? So that times computer could handle 30 users simultaneously. So until 30 users, their jobs were executed, and within their deadlines, whatever they were thinking that I should get response in such a short time, and everyone was serviced within that time, and no one was understanding that there are multiple jobs being run on the CPU, and it was an illusion that every user was thinking that he or she is the alone owner or the main user to be serviced or be serviced by the CPU. Then there is another concept known as multitasking. And in multitasking, we mean that the same user, the one user, performs multiple tasks on the computer. So for example, you as the user of personal computer perform multiple tasks. For example, you are opening the web browser to explore the internet. You are using Microsoft Word, Microsoft PowerPoint, or some other software, application software. So you are giving multiple jobs, and each job could be converted into multiple tasks, and all of the tasks belong to the same user. So in multi-programming, we were concerned that there are multiple users and there one or more jobs are being performed or processed by the CPU. And in multitasking, we are concerned that there is only one user and that user is performing multiple tasks. And in today's computer, multi-programming is used in single user and as well as multiple users. So in both ways, we can implement the multi-programming. So if we summarize today's module, we have learned some very basic concepts of operating system known as real-time processing, starting from interactive processing, and then time sharing, multi-programming, and multitasking.